that you need to know is that a geometric series is a sum of all the terms in a geometric sequence. Remember, we did the arithmetic series whereby you add all the terms in an arithmetic sequence. So for a geometric series, we add the terms in a geometric sequence. Right? When we add them, we can get a sum of the terms in that series. So we need a formula to calculate the sum of terms in a geometric series. So that formula or formulae, there are actually two of them. There are two formulae. You can decide which one you prefer. The first one is Sn. Okay, let me use this column here. The first formula to calculate the sum is Sn equal to A times r to the power of n minus 1 over r minus 1. Okay? So you can use that formula to calculate the sum of terms in a geometric series. Okay? Now, this formula can also be written as Sn equal to A times 1 minus r to the power of n all over r minus all over 1 minus r. Okay? So it can be written like that. Either way, you get the same answer. Okay? But your r cannot be equal to 1 because if r becomes equal to 1, that denominator becomes what? What is 1 minus 1? 0. So the denominator becomes 0 if the common ratio is equal to 1. Therefore, when you are doing calculations on the geometric series, you cannot have a common ratio which is equal to 1. That's not possible. Okay? Otherwise, you cannot be able to calculate the sum of that series. Alright? So, the A, it stands for the first term, T1, which you already know. So this will be T1. Okay? The R is the common ratio, which is equal to T2 over T1. It's also equal to T3 over T2, T4 over T3, and so on. Sn stands for the sum of those terms in that series, or the sum of the terms in that geometric sequence. Then n is the number of terms in the series or the number of terms in the sequence. It's the same thing. Alright? The number of terms in the sequence and the number of terms in the series, they're exactly the same. Alright? So you need to memorize this formula. Fortunately, when you write metric, they are provided. Okay? The formulae are provided when you write metric. Yes. Alright? But you need to know when to apply them. Okay? Alright? I expect everyone to pay attention. You need to be looking on the board. Right? Now, you need to remember that for a geometric sequence, the first term is A. The second term is AR. I have discussed this before. The third term is AR squared. The fourth term is AR cubed. The last term is AR to the power of n minus 1. Okay? Pay attention. Right? So you need to know this for a geometric sequence and a geometric series. Okay? Now, the derivation of these formulae is required. Sometimes it can come in examinations. You may be asked to derive any one of those two for formula, including the one for the arithmetic series. Okay? You can't get both for the arithmetic series and the geometric series, but one of them can be asked for you to what? To derive it. Okay, so on the next page, I'm going to show you how to derive the formula for calculating the sum of a geometric series. Okay, I'm giving you an opportunity to copy down those who are copying down. Just try and do it as quickly as possible, please. Yeah. Yeah, but you can save time if you can copy it now. It will be time of your lifetime. Okay. All right. Can I carry on? Right, so I'm going to move on to the derivation. Then I'll do an example. If I have got time before the bell rings, then we can uh, maybe introduce sum to infinity. All right. All right. Hey, can I have your attention? Can I have your attention, please? All right. So let's derive the formula. Right. I'm going to just derive one. The way that you derive the first one is the same as the what? The second one. So I can, I don't have time to do both of them because of time constraint. So what you do is, first thing, we say let, please don't take pictures in my class, please, because I'll send the PDF. Go and wash your face. Wash the whole face, not the eye only. Is there anyone who is absent today? No. No problem. All right. Can you can you stop talking and put down the work, please? I need to move on to to the the next page. All right. Please allow me to carry on. Okay. If okay, if you are behind, you can catch up. I'll send you the PDF soon after. All right. All right. So I've explained everything here. Then let's do an example. What's your problem? Okay, listen. This page here, is some of the things are repetition of what's here. Okay, I had to do that working out because some learners in the red group they didn't understand what was happening with regard to the derivation. So I moved from this page, then I moved on to this page here. But some of the things that are written here is repetition of what's here. Okay. All right. Allow me please to go to the examples. But be aware that this proof is examinable. And I'm going to be your examiner of your test on sequences and series. So I might bring this. All right.